So let's do exercise 5.3. The first question is x square plus 3 is equal to 0 in complex numbers. X square is equal to minus 3. X is equal to root of minus 3, which can be written as root of 3 into root of minus 1, which is root 3i, which means 0 plus root 3i. So second question is 2x square plus x plus 1 is equal to 0. Now it's 2 ones are 2, so 2x square plus 2x minus 1x plus 1 will not fetch you an answer. Therefore, you got to do it using minus b plus or minus root of b square minus 4ac by 2a and minus 1 plus or minus root of minus 7 by 4. And this can be written as minus 1 plus or minus root 7 into root of minus 1, which is I by 4. So like that you can separate out the real part and the imaginary part. So you have quite a number of sums. You can use the same technique and solve it. So I'll go to 7th question. Root 2 into x square plus x plus root 2 is equal to 0. Again minus b plus or minus root of b square minus 4ac by 2a is minus 1 plus or minus root of minus 7 by 2 root 2, which is minus 1 plus or minus root 7 into I by 2 root 2. So thus you can solve these kind of sums like this. I'll just give you a gist of this also. Root 3x square minus root 2x plus 3 root 3 is equal to 0. I would do these sums not by using splitting middle term. Conveniently I'll do minus b plus or minus root of b square minus 4ac 4ac root 3 and root 3 is 3 3 are 9 plus 36 by 2 root 3 is plus root 2 plus or minus root of minus 34 by 2 root 3, which is plus root 2 plus or minus root 34 into root of minus 1, which is I by 2 root 3. And root 34, if you can split it up into anything you can, otherwise leave it like this. Okay, so these are the kind of sums. And a little more is 9th question. X square plus x plus 1 by root 2 is equal to 0. Take LCM. Root 2 x square plus root 2 x plus 1 is equal to, so again minus b plus or minus root of b square minus 4ac by 2a. So from this you can take whatever common. If you can take a 2 out common, you can't, because take there's 2 minus b plus or minus root of b square happens to be just 2. So from this probably only root 2 can be taken out common, so you can just leave it like that. So, and that could be your answer. Suppose I try to take a root 2 out from here, because this is root 2, so this is root 2 into root 2 is 2, so it become root 2 minus 4. Or suppose I try to take a 2 out from there. Let's see what happens. Minus 2 plus or minus. But this should have been 4 for me to be able to take a 2 out. So dividing by 2. If I take a 2 out, I have to write it as 1 by 2. So when you bring it in, it's 4 and becomes a 2. I hope you understand. So but I have taken a 2 out. This 4 will not be there. So it's 1 by 2. It's 1 by 2 minus root 2. So that's how you get 1 by 2 minus root 2 by 2 root 2. In that case, we can cancel off the 2 out and you get minus 1 plus or minus. When you take LCM here, it's 1 minus 2 root 2 by a 2 by a root 2. So something like this becomes the complex part. Having said that, you can also keep without taking LCM. We could have done this procedure using without taking LCM. X square plus x plus 1 by 2 is equal to 0. Where we can take a is equal to 1, b is equal to 1, c is equal to 1 by 2. Then it becomes all the more easier when you solve the quadratic equation as it is. If you see, you get minus b plus or minus root of b square minus 4ac. So it by 2a fetches you a better answer. So this itself is like I minus 1 plus or minus I by 2. So it's minus 1 by 2 plus or minus I by 2. Isn't this a better answer than doing it like this? So let's stick to this method. Even in the case of the previous question, if you see, my answer is not very good. So I would rather, I think this is okay. There's no other choice. But in this sum, instead of taking LCM, if you proceed like this, you get a better answer. So that's what it is. Okay. So you can any sums that comes your way, identify what is A, B, C, and apply it in the formula. Let's do miscellaneous examples. Find the conjugate of 3 minus 2i into 2 plus 3i by 1 plus 2i into 2 minus I. Just multiply it inside. 3 2s are 6 plus 9i minus 4i minus 6i square. And I square is minus 1, so plus 6. 6 plus 6 is 12 plus 5i. The numerator, let's look at the denominator now, is 2 minus I plus 4i minus 2i square. I square is minus 1, so it's plus 2. So 12 plus 5i by 2 plus 2 is 4 plus a 3i. And you have to get this in standard form. A standard form of a complex number is this, writing it as a plus ib, the real part, and this is the imaginary part. So multiply and divide by 4 minus 3i and 4 minus 3i, which is the conjugate of, it's like rationalizing almost, writing the conjugate, multiplying, dividing by its conjugate. This is a square minus b square should become plus b square because of I square. 16 minus 9i square. I square is minus 1, 16 plus 9, therefore it is 25. The numerator, you have to take it in. 12 3s are 36. 12 4s are 48. Minus 12 3s are 36i. Plus 5 4s are 20i. Minus 5 3s are 15i square. I square is minus 1, so plus 15. 48 plus 15 is 63 by a 25. And solving this, it will become minus 16i by 25. Minus 16i by 25. The question is, write the conjugate of this. The first 12th example sum in my textbook, it's an example sum. Write the conjugate, find the conjugate. First, you're solving this whole question to get it in a standard form, and this is called the complex number z, and the conjugate of complex number is written by z bar, which is 63 by 25 plus I into 16i by 25. The conjugate means this becomes a plus. A conjugate of a plus ib is a minus ib. Okay, I hope you're clear. That's the answer for that one. So let's go to the 13th example. A 1 plus I by 1 minus I. Find the modulus. Modulus, first get it in standard form. So multiply and divide by 1 plus I, 1 plus I. A square plus b square. So this will be 2. You know I square is minus 1. So 1 plus I the whole square. Expand it is 1 plus 2i plus I square, which is minus 1. 1 and minus 1 get cancelled. 2 and 2 get cancelled. You get I. Which means this is 0 plus 1i. The complex number should be of the form a plus ib. A 1i is 0 plus 1i. And they are asking me to find the modulus of the complex number. If the complex number is of the form a plus ib, the modulus of the complex number is root of a square plus b square, which is 0 square plus 1 square, which is just 1. So and they're asking us to find just the modulus of the complex number. So next is this 14th example sum. If x plus iy is equal to a plus ib by a minus ib, prove that x square plus y square is equal to 1. Generally, I'll use properties to do this sum. The property is z1 by z2. The magnitude of it is magnitude of z1 by magnitude of z2. So you were finding you're going to apply modulus on both sides. Modulus of x plus iy is equal to modulus of a plus ib by a minus ib, the whole modulus. And you know the magnitude of this is root of x square plus y square. And this can be written using this property as mod of a plus ib separately, and mod of a minus ib separately, which is root of a square plus b square by root of a square plus b square. And cancel it, becomes 1. Squaring both sides, you get x square plus y square is equal to 1. Basically, I'm doing modulus on both sides. Modulus on both sides. And applying this property, I get an answer. But in the textbook, you would have seen that they would have rationalized this. Now, they would have taken x plus iy to be a plus ib by a minus ib, and they would have multiplied by a plus ib by a plus ib. The denominator will become a square plus b square. The numerator will become a plus ibd whole square. On expanding, you get a square plus 2abi minus b square, because I square b square is minus b square, by a square plus b square. So this is what is x plus iy. Let's further write it as a square, the real part separately, plus I into imaginary part separately. The one with the I is the imaginary part. And now, then they'll apply modulus on both sides. This is root of x square plus y square is equal to root of a square minus b square by a square plus b square the whole square, plus b square, which is 4a square b square by a square plus b square the whole square. So what will be the LCM like is a square plus b square the whole square. And when you expand the numerators, a to the power 4 plus b to the power 4 minus 2a square b square plus 4a square b square. So what would that become? Is root of a to the power 4 plus b to the power 4 plus, this is a 4, right? 4, and so it's plus 2a square b square by a square plus b square the whole square, all within root. And this numerator can be written as a square plus b square the whole square, and a square plus b square the whole square. The whole thing becomes a 1, and root of 1 is 1. So squaring both sides, you get x square plus y square is equal to 1. This is an alternative method, but this is so easy using properties. See what your teachers are expecting from you. Based on that, you can write your answers. Okay, so I'm teaching you both the methods. The using property is damn easy. So let's go to next sum. Is the example 15, where there's a complex number 3 plus 2i into sine theta by 1 minus 2i into sine theta. They've given it as purely real. Purely real means there's no imaginary part. The coefficient of I should be 0. So let's, first of all, we don't want I in the denominator. So let's rationalize it, or multiplying, dividing by its conjugate. It's 1 plus 2i sine theta by 1 plus 2i sine theta. The denominator is a square plus b square, because I square itself is a plus ib into a minus ib. It's a square plus b square, and just multiplying the numerator is 3 plus 6i sine theta plus 2i sine theta plus 2i square sine square theta, and you know I square is minus 1, and so therefore these two are solvable. No, therefore you can consolidate the real part, which is 3 minus 2 sine square theta is the real part. The imaginary part is 8i sine theta. I square is minus 1, right? 2 2s are 4. There has to be, when multiplying, it's 4 I square sine square theta, sorry. So there has to be a 4 plus 1 plus 4 sine square theta. And you're solving the, you write the real term separately and the imaginary term separately. In this question, they said this purely imaginary, purely real, which means imaginary part is 0. So 8 sine theta plus 1 plus sine square theta itself is 0. Therefore, 8 sine theta is equal to 0. As sine theta is equal to 0, this will occur when theta is equal to 0, theta is equal to pi, theta is equal to 2 pi, 3 pi, dot dot dot, general formula n pi, where n is an element of z integer. So let's go to example 16. This is from the old edition. So you must learn all these sums from old editions. Cos pi by 3 plus I sin pi by 3. Z is equal to I minus 1. A cos 60 is 1 by 2 plus I sin 60 is root 3 by 2. So 2 can come out. I minus 1 by 1 plus I root 3. And that's what you get. And then you can rationalize this. So by multiplying and dividing by 1 minus I root 3 by 1 minus I root 3, the denominator will become a square plus b square is 1 plus 3, so 4. Yeah, and the numerator, and there's already a 2 and the 4 and 2 get cancelled. Numerator becomes I, so I minus I square root 3 minus 1 plus I root 3. I square itself is minus 1. So therefore you can write it as black color, I plus root 3 minus 1 plus I root 3. So consolidating the real part is root 3 minus 1 by 2 plus I into root 3 plus 1 by 2, and that's how you get the real part and the imaginary part. And so that is what is this complex number when I solve it. And the question is, just find the complex number, that's all. This is the complex number. What's the real part and what's the imaginary part? That is enough. So let's go to the next question. Evaluate I to the power 18 plus 1 by I the whole to the power 25 the whole to the power 3. I to the power 18 is I to the power 16 into I to the power 2. I to the power 16 is 1 plus 1 by I to the power 25 the whole to the power 3, which is I to the power 2 plus I to the power 24 into I to the power 24 is a multiple of 4 in the power, so you get it as this the whole cube. And I square itself is minus 1 plus 1 by I is multiply and divide by I. Multiply and divide by I to the power 3. So this becomes I to the power 4, which is 1. I cube is minus I. So you get minus 1 minus I the whole cube. So A cube. A minus B the whole cube is A cube minus 3A square B plus 3B square A minus B cube. What is A? A is minus 1. What is B? B is I. Using this, you're going to expand A cube minus 3A square B plus 3B square A minus B cube is I cube. So it's minus 1 minus 3I. I square is minus 1. Minus 1 minus 1 becomes plus 3. Minus I cube is minus I. So plus I. So consolidating the real part, the answer is 2. The imaginary part is 1 minus 3, which is minus 2i. So you get a 2 minus 2i to be the final answer for this whole thing. Okay, so that's about it. And evaluate. Are they asking us to find the magnitude of it? Let me see. No, they didn't say magnitude. They just said evaluate. Just write it in simple form, and I've written it. Okay, so let's go to the next question. The second question. Yeah, it's recording. So for any two complex numbers Z1 and Z2, prove that the real part of Z1 into Z2 is equal to real part of Z1, real part of Z2 minus imaginary part of Z1, imaginary part of Z2. First of all, such sum comes, you should assume the complex number Z1 to be A plus IB and Z2 to be X plus IY. So that we can proceed. And you want to multiply Z1 and Z2. That's what this says. So A plus IB into X plus IY. When you multiply this, you get AX plus AIY plus BXI minus BY, because BY I square is minus 1. And they're asking you consolidate the real and real part. AX minus BY is the real part, plus I into AY plus BX is the imaginary part. And they are saying the real part of this, which means just AX minus BY is the answer for left hand side. Go to the right hand side. Let's solve the right hand side. Real part of Z1, can you see from here, the real part is just A, into real part of Z2 is X, minus imaginary part of Z1 is just B. Don't take the I, imaginary part, the coefficient. Imaginary part of Z2 is just Y, and you got LHS to be equal to RHS. So let's go to next sum. The third question is 1 by 1 minus 4i 1 by 1 minus 4i minus 2 by 1 plus I into a 3 minus 4i by 5 plus I. You're supposed to write it in standard form. So just take LCM 1 minus 4i into 1 plus I, which means the 1 plus I goes there, minus 2 into 1 minus 4i goes here. Let's solve only this part first. So open the bracket 1 plus I minus 2 plus 8i by a 1 plus I minus 4i minus 4i square. I square is minus 1, so plus 4. Solve the real and real, which is minus 1, imaginary plus 9i. Denominator also real and real, which is 5, imaginary is minus 3i. Now you solved only this part, right? You have to multiply it with 3 minus 4i by 5 plus I. So now again do the same multiplications in. So you get 25 plus 5i minus 15i minus 3i square. I square is minus 1, so plus 3 minus 3 plus 4i plus 27i 36i square. I square is minus 1, so you can write plus 36. Solve the real and real. Imaginary 31i by the real and the real. Imaginary and then get it in standard form by multiplying and dividing by its conjugate. It's a square plus b square. Correct. And what is a square? 28 into 28. 8 8 is 64. 8 2 is 16. 22. 8 2 is 16. 2 is 4 5. So 784 plus 100, because it's a square plus b square, so it will become 884. The numerator, you have to now take it in and solve it. It is 33 plus 31i, right? Or is it plus 31i. So you have to take it in like this and multiply, and then you will get the final answer. And what is 33 into 28? 8 3 is 24, 8 3 is 24, 25, 26, 3 2 is 6, 4, 12, 8, 9, 24 plus 330i plus 28 and 31. 8 1s are 8, 8 3s are 24, 2 1s are 2, 3 2s are 6, 8, 6, 8, 868. 31 into 28i plus a 310i square. I square is minus 1, so become minus. The real and real can be solved, so it will become 614 plus the imaginary is 868 and 330. When added gets you 1198i by 884. And on cancelling this, you will get 307 plus 599i by a 442, and that's your answer. So let's go to next question. So just reducing to standard form. Okay, so fourth question is, if x minus iy is equal to root of a minus ib by c minus id, prove that x square plus y square the whole square is a square plus b square by c square plus d square. And now first I'll square both sides because I don't want the root. So it's x square plus y square minus 2xyi, because a square, I square is minus 1. So I've already